In this video, we'll look at factoring a perfect square. So what do we mean by a perfect square? Well, a perfect square is one thing that's all squared. So we could start, for example, with a number 2 and talk about 2 squared. That's a perfect square. Happens to work out to 4. But our thing that's squared doesn't have to be as simple as that. So here's another example of a perfect square. It's a binomial, two-termed expression, and it is squared as well. So we would call that a perfect square. And there are lots of other more complicated versions of a perfect square that we can look at, but for now let's consider this. So remember, this perfect square here means that we have 2 copies of this x plus 3 that are multiplied together. So we'll have x plus 3 times x plus 3, and we can then expand that, and when we expand that, just a reminder, we would do x times x here. That would give us an x squared, and then we would do x times the 3 over here, which would give us a positive 3x. And then we will repeat that process with the second term. So the idea here is that we multiply every term in one of the binomials by every term in the other. So that would give us a 3x here. And then we would finally do the 3 times 3, which would give us a positive 9. We can then collect like terms. You can see here that we have some like terms, a 3x and a 3x. So we have an x squared, 3x plus 3x would be 6x, and we have a 9 out here. So going from here to here is what we would call expanding. And going the other direction is what we would typically call factoring. And what we want to do today is we want to talk about factoring a perfect square. So this is a perfect square. Now the question is, how do you know how to go from here to here? And how do you recognize it as a perfect square? So the first thing to recognize if you're looking for a perfect square is that this should be a perfect square. So this first term should be a perfect square, and so should this last term. So we can write x squared as x squared. Not much changes here. We'll keep the 6x, and then we'll also change this into a perfect square as well. So again, we're looking for perfect squares, numbers that we can write as squares. And that's a valid expression. And it turns out that when you have a perfect square and you want to factor it, as long as you can write that first term and that last term as perfect squares, maybe we'll just quickly do that. And the other thing here that I was going to mention is that if the product of these 2 terms doubled is equal to the middle term, then it's a perfect square. We'll see what that looks like in a little bit here. When we go ahead and factor this, we know that when we factor, we're going to have 2 terms that get multiplied together. And we already said that this first term was a perfect square. So we can put one of those x's in the first set of brackets and the second x in the second set of brackets. And the reason for that is that when we do the expansion, x times x will give us the x squared term. And then lastly, I shouldn't say lastly, there's one more thing after this actually. This last term is a 3 squared, so we know that a positive 3 here times a positive 3 here will be equal to a plus 9, or 3 squared. Now, the last thing that we need to check on is what I mentioned earlier, is that the product of these 2 terms doubled should equal the middle term. If it doesn't, then it's not a perfect square. So what I mean when I say the product is, take these 2 terms, for lack of a better term, I'll call this the a term and this the b term in our binomial. If we take a and b and multiply them together, x times 3 will give us 3x, and then we double that, we'll get 6. So maybe just on the side here, 3 times x would give us 3x, and then we double that. Let's see if we can squeeze that in there. That's a 2. Would give us 6x, which is our middle term here. So if that's the case, then this is going to be a perfect square. If not, then it's not a perfect square, and you might need to look at a different way of factoring. Now you can see that we have an x plus 3 multiplied by an x plus 3. That's the same thing multiplied by itself, and a short way to write that is just x plus 3 squared. So that's how we can factor a perfect square. Let's try one that's a little more challenging now. Same idea and same principles. We'll do this one here, this 9x squared plus 24x plus 16. So right off the bat here, we should recognize that we could rewrite this whole thing as 9x squared is a perfect square. We could take the square root of 9x squared and we would get 3x. So let's rewrite that as 3x all squared. We'll keep the 24x here. And then we have 16, which is also a perfect square. 16 we could write as 4 squared. Now, just like we did over here, as long as we can take the product of these two perfect squares, the product of these numbers that we've written now as perfect squares, so 3x times 4, maybe I'll just write that off on the side here in the margins. So 3x times 4, and as long as we can double that and get 24, then we're in good shape. So 3x times 4 is equal to 12x times 2, and 12x times 2 is 24x. So these two things are equal. This must be a perfect square. And the way that we're going to factor that perfect square, two sets of brackets. At the front of each bracket, we're going to put the 3x, because the 3x multiplied by what will give us 9x squared? Well, that has to be a 3x. And we know at the back end, we're going to need a 4 to give us the 16. So 4 here and a 4 here. So when we multiply those, we get that 16. And again, both of these terms both of these factors, pardon me, are the same. So we could rewrite this as 3x plus 4 all squared. Once you've done enough of these and you've had enough practice, you might be able to kind of shortcut the process a little bit. But if you need to, you can write out all of these steps. So that's how we can factor a perfect square. The idea here is that as long as the first term and the last term are perfect squares, this is a good candidate for a perfect square. We look at the square roots of each of those, and if the product of those square roots doubled is equal to the middle term, then it's going to be a perfect square. The first term can go at the beginning of each bracket, and the second term, the second sort of square root, so the square root of 16 can go in the back of each bracket. Again, some of you will figure out how to do a shortcut here. This is the square root of this at the beginning of each bracket, the square root of this at the end, and just double checking again to make sure that those numbers doubled, the product of those numbers doubled will give us this one. Because things change. If I suddenly change this 24 to a 23, then this method doesn't work anymore. So keep that in mind. All right, hopefully that helps with factoring a perfect square.